So today's topic is going to be a combination of two different ones. That it's going to be a perfect square trinomial with difference of squares. In this case, we will combine two factoring cases. Since we have the possibility of having a perfect square trinomial structure that we can factorize, and then a result will be again factorized as a difference of squares. So in this case, the step is going to be first order the polynomial to see the perfect square trinomial clearly. Sometimes that ordering can be different than alphabetical order because the important part is to have identify the perfect square trinomial and the difference of squares then. So that's why sometimes maybe can be a little bit different than alphabetical order. Then we will need to factorize the perfect square trinomial and convert the polynomial into a difference of squares. And finally, we will factorize the difference of squares. So let's see. In the first example, it's very simple because we have it ordered. If we check this part has a structure of the perfect square trinomial. Why? Because the first one has a specific square root that it's m. The third one has a specific square root that it's 1. And if we multiply those times 2, we will get the middle one. So this one, it's a perfect square trinomial, so we can factorize it as m plus 1, all of it squared, minus 4n squared. Now I have a difference of squares, so I will open up a bracket and another one. So it's going to be, remember, the one that it's positive, it's going to be positive on both parentheses. The one that it's negative, it's going to be positive on the first one, negative on the second one. And then our answer is going to be m plus 1 plus 2n. That multiplies m plus 1 minus 2n. And in this case, if I order it correctly, our answer is going to be m plus 2n plus 1. And finally, m minus 2n plus 1. And that will be our final answer. So it's not a difficult topic. We need to look for the perfect square trinomial and then factorize it as a perfect square trinomial, and after that doing the difference of squares. So let's see another example. So the next one is going to be something like this: y squared plus 9 minus 6y minus c squared. So remember, we need to order the polynomial to see the perfect square trinomial easy. In this case, to see the perfect square trinomial easy, it's going to be minus 6y plus 9 and finally minus c squared. Why? If we check out this part, this one has a specific square root that is y. This one has a specific square root that is 3. If I multiply those times 2, I will get the middle one. So this one we can factorize it as y minus 3, all of it squared, minus c squared. Then, of course, I can open up my brackets because I will do it as a difference of squares. We have here a difference of squares, so we can do it like y minus 3 plus y minus 3 minus, and it's going to be c and c. So our answer is going to be y minus 3 plus c. And in the other parenthesis, it's going to be y minus 3 minus c. So if we order it correctly, it's going to be y plus c minus 3. That multiplies y minus c minus 3. And that's going to be our final answer. So as I was telling you, it's not a difficult topic. We only need to look for the specific part of the polynomial that is the perfect square trinomial, factorize it, and then we will have a difference of squares that will be factorized also to get our answer that it's going to be two different polynomials in parentheses multiplying. So let's see another example. So let's check this example. We have 49m to the 4 25m squared minus 9n squared plus 30mn. Of course, these ones are going to be the ones that are on the perfect square trinomial, since the middle term that it will going to be 30mn. Mn, remember we need to have the square root of the power, so m squared, the square root is m, the square root of n squared is n. That's why those are the three ones that are going to be part of the trinomial. But in this case, you check out that the ones that have a square root are negative ones, and the square root of negative numbers, there are imaginary numbers, they don't exist. So in this case, what we need to do is something like this. We will put the 49m to the 4. If we order it to see the perfect square trinomial, it's going to be minus 25m squared plus 30mn minus 9n squared. But in this case, as I was telling you, it's impossible to take out a square root of a negative number. I mean, it's an imaginary number. So in this case, we can do this specific little trick. We can take out the minus sign, and it's going to be on the inside part, 25m squared minus 30mn plus 9n squared. Then this one will be a perfect square trinomial. So we can put it like 49m to the 4. In this case, it's going to be 5m minus 3n, all of it squared, because 5m it's the square root of 25m squared, 3n is the square root of 9n squared. If I multiply 2 times 5 times minus 3, it's going to be minus 30mn. So now we have here a difference of squares, so we can do it. We will open up two brackets. On the first one, it's going to be 7m squared. In the second one, also 7m squared, that is the square root of the first term. Then it's going to be on the first parentheses, it's going to be the square root of the second one positive. In the second one, it's going to be the square root of the second one negative. So we can do it, and it's going to be 7m squared plus 5m minus 3. That multiplies 7m squared minus 5m plus 3, because remember this minus sign will change the sign of both terms. It's correctly ordered, so that's going to be our answer for this specific exercise. So in the case as this, when we have negative signs on those terms that have a specific square root, we need to take out the minus sign in order to have it like this. Then, of course, when it's positives, those are positive ones, we can factorize it as a perfect square trinomial. Then we will have the difference of squares as it is here. Of course, when we have the difference of squares, it will be two parentheses with the first square root positive on both parentheses. The second square root is going to be positive on the first one, negative on the second one. And then, of course, that will be my answer. So let's see another example. So if we get something like this, 1 minus a squared minus 9n squared minus 6an, of course, the one that are going to be the perfect square trinomial are those, because the first two have a specific square root, and the third one has the square root of every of the other two, that is going to be a and n. So let's see, in this case, it's very similar than exercise 3. Those that have an exact square root are negative ones, so we cannot have a square root of a negative number. So in this case, what I need to do is we can take out the minus sign, or first we can order it to do it to see the correct order. It's going to be a squared minus 6an minus 9n squared. So now I can take out the minus sign, and it's going to be a squared plus 6an plus 9n squared. So now we can factorize this as a perfect square trinomial, because the first one has a specific square root that it's a. The third one has a specific square root that it's 3n. If I multiply those times 2, I will get the 6an. So my answer is going to be 1 minus parentheses a plus 3n, all of it squared. So we can do now a difference of squares. So I will open up two brackets in this case. It's going to be 1 plus a plus 3n, and in the other one is going to be 1 minus, remember the one that it's minus, it's positive on one parenthesis and negative on the other one. So we will have 1 plus a plus 3n that multiplies 1 minus a minus 3n. So the correct ordered answer should be a plus 3n plus 1, and in the other one is going to be minus a minus 3n plus 1, and that will be my final answer. So it's not difficult, it's only looking for those specific terms that have the structure of a perfect square trinomial, factorize them, and then use the difference of squares to continue factoring the expression and getting the correct answer. So let's see another example. So we can have also something like this, exercise 5. We know that in this case we look at the problem and we see that we have more terms. It doesn't matter, it's because we will have two different perfect squares that will be transforming the difference of squares. So let's see how to do it. In this case, of course, one specific perfect square will be composed by these three, those that have a squared and m squared, because the square root of those it's a and m, so the middle term must have a and m. And of course the other ones will be these three that are also a perfect square trinomial. So let's see how to order it. I will put first the one that it's positive, m squared plus 2am, I'm sorry, a squared, not m squared. I need to start with a squared plus 2am plus m squared. And then I will put the other one that is going to be x squared minus 6x minus 9. So let's check out, as I was telling you on the past exercise, in this case, the second in the trinomial in this case, we cannot take out a square root of a negative number, so we can do a little trick. Remember, we can take out the minus sign in this, and it's going to be x squared plus 6x plus 9. In the other one, it's going to be a squared plus 2am plus m squared. You don't need to put it in parentheses. I put it in parentheses to check out that here we have a perfect square trinomial. Here we also have a perfect square trinomial. Why? Because on the first one, if I take the square root of the first and the third term and multiply them by 2, I will get the middle term. So this one, it will be something like this. In the other one, it's going to be x plus 3, all of it squared, because if I multiply x times 3 times 2, it's going to be 6x. So now I have an exercise that it's a difference of squares. So to solve a difference of squares, we will open up two brackets. The square root of the first term positive on both brackets. The square root of the second term will be positive on the first bracket, negative on the second bracket. So we will get something like a plus m plus x plus 3. And in the other parentheses, we will get a plus m minus x minus 3. Remember, this minus sign will change the sign of both terms. It's correctly ordered, so that's going to be our answer for this specific exercise. So if we get 6 terms in this case, we will need to look for 2 specific structures of a perfect square trinomial. One of it will be a positive one. The other one, we will need to take out the negative sign to be the negative part of the difference of squares, but it will be exactly the same. We will factorize first the perfect square trinomial, then we will get the difference of squares, we will factorize it, and we will get our final answer. So let's see one last example. So on this one, it's going to be very similar because we had 6 terms, so we need to identify 2 different perfect square trinomials. Of course, one perfect square trinomial will be composed by these 3 because the middle term, that is going to be the 10ab, has the square root of b squared and the square root of a squared. So that will be one trinomial, and the other one will be this one. So on this case, if I order it correctly to check out the trinomials or to see the trinomials very easy, it's going to be plus 10ab plus 25b squared. The other one is going to be minus m squared minus 6mn minus 9n squared. It will be something similar as the last like 3 or 4 exercises. We cannot take out the square root of a negative term, so we need to take out the minus sign, and it's going to be m squared plus 6mn plus 9n squared. In the other part, remember, you don't need to put it in a parenthesis. I will put it to see it more clearly, but you don't need to put it in a parenthesis. So in this case will be something like this. This first part will be a perfect square trinomial. This second part will also be a perfect square trinomial. Why? Let's check out. If I get the square root of the first one and the square root of the second one, and I've multiplied them by 2, I will get the middle term. Then it's going to be on the second parenthesis, the square root of the first one, the square root of the third one. If I multiply those by 2, I get the middle term. So in this case, this one, it's a difference of squares. So we can factorize it, and it's going to be a plus 5b plus m plus 3n. And in the other bracket, it's going to be a plus 5b minus m minus 3n. I'm sorry, plus 3n. And it's going to be a plus 5b plus m plus 3n. That multiplies a plus 5b minus m minus 3n. It's correctly ordered, so we don't need to change anything, and that's going to be our final answer. So doing an exercise of a perfect square trinomial combined with difference of squares, it's not difficult. It's only first looking at the exercise, ordering the polynomial to see the perfect square trinomial clearly. It can be 1 if we have 4 terms, or it can be 2 if we got 6 terms. Then we will factorize the perfect square trinomial or trinomials, and it will be converted into a difference of squares. And finally, if we factorize the difference of squares, we will get our correct answer. So that will be it for today's topic, that is called perfect square trinomial combined with difference of squares. Thank you for listening.